Great, so good morning. Welcome back to the algorithms and programming section of Year 11 Computer Science. Today we're going to have a lot of recap of everything that we've learned so far. There are a lot of learning objectives in algorithms and programming half term 9, but that does mean that a lot of it is not new. So it's just building on the stuff that you're confident at already and an opportunity to ask some questions. So we're going to focus on primitive data types, so that's things like integer, boolean, string. In fact, not a string. String isn't a primitive data type. It's just a single value like an integer, a boolean, a character, or a real, or a float sometimes called. We're looking at different types of testing, so you can test for data that is wrong. So if you're asking somebody's age, you can put in potato, that's completely wrong. A valid age on the boundary would be 0 because you can't be less than 0, or valid might be, 15 or something. An extreme might be something like 429,000 would be an extreme age. And we want to be able to test your code so that it works under all conditions. And then we want to be able to actually test the code. So we have a couple of different things that we might want to store. The number of faces on a dice is going to be 6, so you'd expect an integer. And we talked about different primitive data types. So the difference between a real and an integer is a real can have decimal places. A string is a compound data type. It's made up of lots of characters. So you put them together and you can have something like this. And I don't think anything's new here. The only thing that might need flagging up is boolean, remember, means true or false. So you can't store off as boolean, but you can store false. So you can have either true or false as a boolean value. When we're talking about different types of test, the idea of testing is you want to make sure that your program works under every circumstance. If you're driving a self-driving car, it needs to accelerate, it needs to brake, it needs to steer, but it also needs to be able to cope under all circumstances. How does it work in the rain? How does it work when it's heavily loaded? How does it work when the wheels are really run down after excessive use? You need to be able to test under every condition. So valid means normal. So if you're asking your name, a normal name would be any of your names. An erroneous name might be, nothing there at all, so an empty string. Or a boundary name might be a name with 128 characters, because anything more than that might not work in a database or something like that, I don't know. So how can we design data to test all three conditions? Well, if you're asking the user to type something in, anytime you use input, that's when we want to make sure we test it properly. So we want to test this with valid data, like if they type in 3, that's valid. And is the roll more than 6? No, it's not. We've typed in 3, it's valid. How about a boundary data? So if we put in 6, 6 is valid, but it's right on the edge of being valid, so we call it a boundary test. So is roll, and we've said 6, more than 6? No, that's good, so we consider it to be valid. How about something erroneous, like potato? So enter a roll, potato, this is going to crash. So it will still have a runtime error at this point. But if we put an extreme value in, like 472, then it will catch it, because 472 is more than 6, it's going to say it's invalid. So these are valid, these are boundary, these are erroneous. Well, I'd say that they are extreme rather than erroneous. And then I think we just want to move on to the Word document. So you'll find this in half term 9, and it's CT13. We just need to put a definition on. I've said them, but you've got the link as well to be able to try and find them on here. And I'll pause you once we get to activity 2 to give you some help. So we're going to give some clues for activity 2. You've got some code here that won't work by itself. If we have a look at this code and we run it, we have a runtime error because name is not defined. That's because we need to define it, and we're just going to set it to a value. So it looks like it's going to be a string. How do I know it's going to be a string? Well, the name of the variable called name gives us a clue. We'd expect a name to be a string, but also we're trying to work out the length of a name, and that only makes sense for either a list or a string. So let's see. If I say my name is Mr. Dring, the program says that it is valid. Why? Because is the length of the name equal to 0? Well, in that case, it's invalid. If the name of the person is more than 10, then it's invalid. Otherwise, it should be valid. So you just have to say a valid name, which could be that. An erroneous name, which could be too long or too short, or a boundary. So that could be just one character or exactly 10 characters. And you need to give 2 examples of each. So let's go through activity 3 together. I'm going to read through the question. The program's written that takes a number and a name from the user. You've got this code further down in part B if you want to have a look at it. So it asks you to enter a number, asks you to enter a name, and then it will concatenate, join the name and the number. But we need to do some validation. A valid number is between 1 and 99 inclusive. So 1 would be a boundary test for the number, 99 would be a boundary test, 0 and 100 would be extreme or erroneous, invalid data. Any name entered of at least one letter is valid. So when you're thinking about your boundary tests, you need to have one in there that's just exactly one letter long. But if it's empty, the string is empty of the name, it should give you an error message. But it doesn't give you a maximum number here, which is nice, a maximum number of characters for the name. The user ID is created by joining the name and the number. The name comes first, followed by the number. It doesn't say that, but if we look at the code, we can see how that works. The user ID is displayed on the screen. So complete the first 3 columns with test data with all combinations. So we need to have all combinations of something for number and something for name. So if number is empty and name is Bob, that's going to be erroneous because we haven't got a number. Oh, I can't spell erroneous. Erroneous. There we go. What should happen? It should give you a message saying, please enter a number, or just invalid message. We're only filling out the first 3 columns for now because we're going to plan how to test your code. If you work in industry, it should be a different person writing your tests to the person who's writing the code, because you want somebody to logically look at what the customer has asked you to write code for, write out all of your tests, and then automatically run those tests to find out what actually happens. For you, it's going to be the same person writing the tests as actually running the code and actually testing it. But in industry, that's bad practice. You want to have different people involved at every stage. So try and think of all possible combinations of erroneous, valid, and boundary for each of those. Okay, so we're going to go through 3 part B and 3 part C. You should have had a significant number of different tests to test all sorts of combinations of valid data. So I've got a invalid, erroneous section of data on here. I'll pause the video, but can you tell me why this is invalid? So yeah, this number should be 99 or less, and it's not. If we run it, so let's see, enter a number, 120, enter a name, Bob, it hasn't said it's invalid, and it should. So where part B asks us to fill in the 4th column, what actually happens is it generates a username of Bob120. The final column we'll do in part C, and you'll have to look at the logic here. There's something wrong on line 8, which is a logic error. Remember, a logic error is the hardest to find and fix. A syntax error is dead easy because we've broken the rules of the language and it tells us exactly where to look. A runtime error is quite easy to find and fix because it's trying to do something impossible, and at least we still get a clue as to where it's going wrong if it tries to do something impossible. We're trying to convert n into a number. It can't do it, it fails, it crashes. A logic error, the only way you can find it is by thinking what you want your program to do and testing every possible combination of valid boundary and erroneous until you can detect it and then find out what is wrong with it. So I'll let you try and fix the code, but you need to make sure you've got all the sensible tests in, that you work out what it actually happens, and then go back and keep going until you can say, yes, I fixed it, and you can show your code for it. Just a reminder that you need to make sure that your code is uploaded at the end of the lesson. I'll remind you in 10 minutes or so where to get it uploaded. So once you've had a go, you've finished off everything, please make sure you save the Word document first, upload it to Half Term 9, Algorithms and Programming 9, so that you can get your feedback for next time.